Okay, students, let's go to question number 3. So, find the general solution for this second order differential equation with homogeneous and linear constant coefficients. So, you have been told that you see y second prime plus 5y prime plus 4y equals 0. So, in order to find the solution for this, we just simply look for its characteristic equation and try to solve the a characteristic equation, and let you see how I'm going to do. This is the solution. So what we need to do is first we need to determine the characteristic equation, students. So in order to determine that, in place of y, just use m and consider the order of the derivatives as exponents. So what comes here is the following. So this will be m squared plus 5 times m is the power of 1 plus 4 times m is the power of 0, because no derivative here. M is the power of 0 is 1 times 4 is 4. So finally we will obtain this to be m squared plus 5m plus 4 is equal to 0, as you see. And clearly this is a quadratic equation, so it can be obtained by using quadratic formula or factorization technique if it's possible. So here we can use factorization because we can obtain, you see, two numbers where the sum can be number 5 and the product can be 4, and the numbers are 4 and 1. So we can factor this as m plus 4 into m plus 1. And clearly the product of these two comes 0 if either, you see, one of the two is 0. So either m has to be minus 4 or m has to be minus 1. So you see, m is either minus 4 or minus 1. So from this, in order to obtain the general solution, what we need to do is, see, we have to consider the linear combination of the exponential expression of the obtained solution. So y equals c1 e to the power of minus 4x plus c2 e to the power of minus x is going to be the general solution. I hope so simple. After having this, what comes next is question number 4. You are given this differential equation with one solution there. So the question is to find the other solution. Dear students, if you remember very well, we have derived a certain formula in order to find the second solution, provided that the first one is given. For a differential equation having a form y second prime plus p of xy plus f of xy is equal to 0. So in our case, we are going to apply that. So as you see, the first solution is given, that is y1 equals x is given. Even you can verify this by just substituting this x where your d in our differential equation. So if you carry out second derivative of this one, it will be 0. So 0 minus the first derivative of this makes 1. So this will be 1 over x. And here if you put y to be x, it will be 1 over x. So negative 1 over x plus 1 over x makes 0. So it's true that this y1 equals x is the solution for the given d. So as I said, in order to find the next solution, what you need to do is, you see, you have to apply the formula we derived. y2 is y1 into e to the power of minus integral of p dx over y1 squared dx. Now here what you need to do is, see, you need to identify what p is. Your p is nothing, but it is a coefficient of y prime, student. And the coefficient of y prime, as you see, is negative 1 over x. But you have to be careful that such p is selected after you write the given dE in terms of what is form. That is y second prime plus p of xy plus f of x times y is equal to 0. Make sure that the coefficient of the second prime is 1. And make sure that everything is written in terms of y second prime plus p of xy prime plus f of xy equals 0. So now it is clearly here, it has been obtained that p is negative 1 over x, and y1 is also given as x. So we can directly substitute these values here in their corresponding position. So your y2 is going to be like this. Your y1 is x, directly used, is a power of minus integral of p is negative 1 over x dx. So y1 squared is going to be x squared. So simplifying this, we can obtain this x into e to the power of, is a student here, negative of negative 1 over x is positive 1 over x, and that is ln x. So x into e to the power of ln x over x squared can come, and we knew that e to the power of ln x is x, and x over x squared makes 1 over x. So clearly this integration makes x into integral of 1 over x dx. So from this, what comes is y2 is equal to x into x over x squared dx. And from this, we can cancel 1x by 1x, and 1 over x dx can come. And finally, y2 comes to be x ln x. We are not asked to find the general solution. Had we been asked to find that, we could have combined y1 and y2. The question is to determine the other solution. So here we obtain the other solution is y2, so y2 is x ln x. That's it. After having this, what comes next is question number 5, the workout part. So here, the velocity v of an object of mass m falling in the Earth's atmosphere with air resistance, which is assumed to be proportional to the velocity, satisfies dv by dt plus p over mv equals g, where g is a constant acceleration due to gravity and p is constant of proportionality for air resistance. So the question is to find the velocity of a 70 kilogram skydiver after 20 seconds from a helicopter with v at 0, 10 meters per second. Assume the motion effect of the helicopter is neglected and g is 10 meters per second squared and p is 10 kilogram per second. So now you are asked to find first the velocity at any time t. Once you obtain that, you can directly substitute the given information. So the procedure goes like this. So first, let's take the given differential equation, dv over dt plus p over mv is equal to g. So this is dv over dt plus, look here, p and m are not varying, they are constants. P is 10. You have been told that p is 10. Had it been, see, a variable expression, this could have been given in terms of t. So, but now we don't have t, so we simply plug 10 directly in place of p. And m, the mass of the skydiver, is already given, it is what, 70. So you can have that here. Again, the mass is not varying, so we can directly use that one. Then we have v is equal to, g is already given, it is 10. So we have this. So simplifying this, dv over dt plus 1 over 7v minus 10 equals 0 can come. I just brought 10 to the left, and minus 10 is here. Students, basically, this can be done as follows. We have derived a formula for this. Basically, this is a linear expression. So for a linear differential equation, we have derived a formula which actually was this: I, the integrating factor, is equal to e to the power of the integral of p of t dt. Here I used p of t because everything is given in terms of t. The one we knew before was p of x, but now, see, it is given in terms of time, so in place of x we need to use t. So e is the power of the integral of 1 over 7. P is known, it's 1 over 7, directly obtained from, you see, this one. It's directly obtained from the coefficient of v. So it is 1 over 7. E is the power of 1 over 7 t can come. Then once you obtained I, the general solution v can be obtained by using this formula as we derived. So here I is the one we obtained here, the integrating factor, right? Because I is already determined here, and c is an arbitrary constant number, and f is nothing but it is negative 10, you see. So substituting that, 1 over I means 1 over this number, so we can bring this 1 over 7t up and can have negative 1 over 7t as you see. C plus the integral of what's f, it's minus 10, and I is already done, e the power of 1 over 70 dt. So from this, v is going to be negative 1 over 70 into c, you can take this 10 out, and minus 10 is the power of 1 over 70 dt. So the only thing left here is to integrate this one. So from this, v of t is going to be e the power of minus 1 over 70 into c minus 70 is the power of t over 7. So here we finish. The velocity at any time t is given by this one. But you have been also given here that in order to avoid this, velocity at 0 is 10. So let's put 0 here and equate this with 10 in order to find what c is going to be. So v at 0 is 10, as you see. So put 0 in place of t and equate that with 0 as can be shown here. So this is going to be, look, this comes 1 and c minus this comes 1 again. 10 is equal to 70 equals to 10. So the value of c comes to be 80. So v at t will be this one. We were having c to be c was appearing here, but now c is obtained, so directly substitute that here. It is 80. So this is going to be the particular solution, but you are asked to find the velocity of that skydiver at 20 seconds. So v at 20 is going to be, put 20 here in place of t, it will be this much. So in order to find the exact answer, you may use a calculator, but no need of using calculator in exam. So you can put your answer in terms of this as you see. Thank you.